All right. If you are watching this, then that means you are ready to try to challenge yourself. Awesome. What we're going to do now is we're going to find the volume, but instead of finding how many 1 inch by 1 inch by 1 inch cubes, in this case, because we're talking inches, we're going to say, what happens if I cut my inches, my cubes, sorry, in half, both by length, by width, and by height? How many can I fit then? So if I'm thinking about that and I'm saying, okay, here's a 1 inch cube, here's a 1 inch cube, I'm trying to see how many will fit in here. What happens if I cut them in half? Okay, you're going to fit twice as many going in the length. Then you'll fit twice as many going in the height, and you'll fit twice as many going in the width or the length. So you're actually going to fit a lot more cubes if you make them smaller. But how many more cubes? So that's what we're going to figure out in this problem. The first step to solving this is you need to find the volume still. And this was the same one we did in the very first example. Okay, if we do length times width times height, right? 10 times 4 times 6. And we know that that came out to be 240 cubic inches. Okay, that would be, there's 240 cubes that could fit in there if they were 1 inch by 1 inch by 1 inch. But we are saying they're not 1 inch, they're only ½ inch. So you can fit twice as many going this way because they're half the size, right? Twice as many in the length, twice as many in the width, and twice as many in the height. Because when you split something in half, you can fit twice as many of them. Okay. So there's two ways you could go about this. You could literally do 2 times 10, which would give you 20. Then 2 times 4, which would give you 8. And then 2 times 6, which would give you 12. And you could solve again for the volume now. What would the volume be now? So you would do 20 times 8 times 12. 20 times 8 is 160. 160 times 12, I would plug into my calculator, and I got 1,920. So you could fit 1,920 of these size cubes in your rectangular prism. Okay, so that was one way we could do it. We could multiply the length times 2, the width times 2, and the height times 2 because they're ½ inch, and then multiply and find the volume. The other thing you could do is if you already found the volume right here, then all you have to do is say, okay, that is times 2 times 2 times 2, and 2 to the third power. 2 times 2 times 2 is times 8 altogether, right? 2 times 2 times 2 is really multiplying everything times 8. So if you're taking this volume and you're multiplying it by 8, which is 2 times 2 times 2, and then that would come out to be the same 1,920. So it's two different ways. So now we're going to look at an example that has those mixed numbers involved. And I'm going to go through quickly because I don't have a whole lot of time on this video. The first thing we're going to do is we're going to change all of these. I'm looking at the denominators. These can be changed pretty easily into decimals. So 3 2/5 would be 3 4/10. 5 1/2 is 5 1/2 is 0.5. And then 2 3/4 is 2 7/500. Okay, then I'm going to find you could do it both ways. So it says there's still ½ by ½ by ½ cubes. So you could multiply each of these by 2 and then find the volume, length times width times height. Or in this case, I'm going to do 3.4 times 5.5 times 2 7/500. I'm going to find the volume as if it were normal, how many 1-inch cubes would fit in. I'm going to plug that into my calculator. And I got 51, see if I can squeeze it in here, and 425 thousandths. Okay, that would be a normal volume if I was going 1 inch by 1 inch by 1 inch, but I'm not. I can do twice as many in the width, twice as many in the height, and twice. So that's times 8. So I'm going to do that 551 and 425 thousandths times 8. And I'm going to do that in my calculator. And I got 411 and 4/10. So that would be your new answer. That's how many of those ½ inch by ½ inch by ½ inch cubes fit.